Alright, I did enough work to do some initial testing, and I have over here my DCC system, which consists of a Raspberry Pi running JMRI with a wireless access point on it, and here is a Sprague 3. This is the DCC command station, power supply for the track, power supply for the Raspberry Pi, and I have a 3.5-inch screen on it. So this is my computer to run JMRI on. And I'm connected via this, which is an ESU ECOS remote running engine driver. And now you could be running in any of your cell phone or your tablet or anything else and connect to the Raspberry Pi as well, but I'm doing some testing, and that's part of my testing. So I have this little tiny engine here, and as you can see, these connectors are making it really bumpy, but the little guy will run down there fine. Now I have no bus connected here, so these turnouts are, when I flip them, will transmit power to the other section. So when you see it come across this way, that's what it's doing. Now I can't go much further because there's a join here and those are in the way. But we'll go back again and show you going this way. This is going to be to the turntable. In fact, it's going to be from the turntable, because this whole section is returning back. But just to show you that works, this guy works, and just to show you the power routing, if I flip this to the siding and give it throttle, nothing happens. And as soon as I flip the switch, routes power, and away we go. So that's my initial test to make sure things are working. In the overall setup, this is the main entry track here, and if you want to go to the turntable, you'll come off through here into the turntable and then do all the turntable stuff here. To come back from the turntable, these next two tracks will come back and then join in, or to switch into one, and then you're back. And of course there's all the turntable stuff. I haven't got the turntable wired in my test mode yet, and I'm planning on doing that tomorrow, and then I'll be able to test the turntable out fully and run it back and forth as well. But I'm real happy with this Raspberry Pi. It auto-detected my Sprague 3. I'm going to move to a DCC Plus system soon when I get all the components, and mount it all on a small board, and then have access to something. It's a little bit bigger than this, but not a heck of a lot bigger. So that'll be my test system for testing stuff out. The only other thing of note is this here turnout, I think it was, could have been this one of these two, the area in between the point rail and the main rail was a little dirty, and I used an emery board, some emery cloth just on it to clean it up. When it's power routing, you're going to get that. Now the way I've got the bus set up is there's bus wires dropped here, here, here. So if it doesn't power route, it's not going to matter. The only time it's going to matter is when I'm working in the turntable, because the initial setup of the turntable is all of these tracks are powered by the turntable. Now if there's a bad electrical connection in here or along here, and I'm not soldering those, then that could cause some issues. But I'm going to drop feeder wires just in case, so I can create a bus later on if I have to. Anyway, that's tonight's.
What I have here is, this here is a DCC Plus system. So this is a complete base station. And this is power in. I have over here 14 volts, 3 amps. And at track, it comes out to 13.1, 13.2. Maybe upside down for you. Anyway, it comes out at a little bit over 13. That's normal. And with the DCC system, power's in here. This is track power. This is programming power. If you can see, the lights are on here indicating that power's on. If I were to turn power off, I would have to go on here, turn track power off, and you saw it's off. I'm controlling this through my iPad. This is a Gen 2 iPad running WI throttle, Wii throttle. So I'll turn track power back on and see the lights are back on. Now this is hooked up to JMRI running on a Raspberry Pi. The Raspberry Pi is here. Optionally, I've added a 3.5-inch screen on here so that I can kind of see what's going on, but it's not necessary. And then the Pi connects into the Uno with a motor shield on it just through USB. So when you power up the Pi with the wall wart here, it powers up the shield as well. And so all you need for this is track power and power to run the Pi, and then everything will run. If you go online, you can look at DCC Plus, and that'll give you all the information for this. If you look for JMRI and DCC Plus, you'll see how to build this. If you have a laptop, that's what I used to use here, is a laptop in place of Raspberry Pi, but I thought in Canada it's like $60 for the little computer. In the US it's about $35. Now I added some things like a, to me, $20 keyboard that will connect with it. As I say, the screen's about $35, $35 to $40. You can get a genuine motorboard and genuine Uno for about $50 in total. So $50 for this, another $10 or $15 for the power supply, and then you got to pay $10 to ship it because they always charge you for some reason. So maybe $75 for a DCC base station. I probably have $100, maybe $125 in here with a screen and keyboard. If you've got a screen and keyboard available, you could do all the programming and just run the Pi, and then you're down to $60. So you're, I don't know what the total cost is, $150, certainly under $200, and you have a complete DCC. Now to run it, you need a smartphone or a tablet of some kind. So the little guys there, as I increase, you can see it runs. If you're familiar with JMRI, that's all it's doing, is just running JMRI. So I can run anything on the layout with it. And depending on the power supply you get, as I say, this is a 3 amp one. It'll do a decent job on a dozen locomotives simultaneously, I'm guessing. Now power is being routed through these switches because I don't have the bus set up yet. And the track isn't the cleanest track, so sometimes, especially when it's such a tiny little engine with a tiny little wheelbase, sometimes needs a little help until I clean the track. All I'm doing in JMRI, I have the throttle set at 20%, and I let it run, and when I want to move it, or reverse direction, I go from forward to reverse, and it'll come back. Now I can't run any further because there's no power in there. But my project was to get DCC Plus running and then fueled from JMRI on a Raspberry Pi, which I've now managed to do. I'll let that come back. There's a 10% throttle. These are insel frogs. See, it still goes over the insel frog okay. 5% throttle. It's not going to be pulling a lot at that. I just put it on here to test because it's short wheelbase and it'll detect if there's issues in turnouts or if it picks anything. I do have to test with something long as well, but I'm not going to test with anything long until I get the buses installed. I'll go in reverse on this. 2%. There's throttle setting 1. It's not the finest throttle setting. I haven't done any programming on it yet. Hi folks, Don Martin here, back again, and I want to talk to you about DCC Plus today and the cost of what I have here. I went ahead and created a DCC Plus system. Now the system itself is an Uno plus a motor shield, and the motor shield needs 2 wires. These are just normal wires that I use for feeder wires to drop to the bus, and I just stripped a little bit off and plugged them in. So they work perfectly. You don't have to buy anything special. What I have here is a connector to plug my power supply in and a connector to plug track power in. Again, you don't need to do that. You can plug you can have your power supply go directly in here, and then your bus wire goes directly in here. I wasn't sure on the cost, and I thought maybe 50 bucks or something for those. So I went on to Amazon today. Sorry, I went on to eBay today. Today's September 14th. The Uno, so the guy on the bottom here, is $8.91, and that's Canadian. It'll get here between October 16th and December 6th, so September, October, November. It could be 3 months. Now, if you want to pay $30 instead, you can get virtually next day delivery, but I thought that was a bit much and I wanted to see what I could do on the cheap. The motor shield is less expensive. It's $777. That's the one on top here. And it gets here between October 2nd and December 16th. So, you know, it could be 3 months before I get the parts that I need. Now, I ordered a cheap motor shield before and it didn't work. And I contacted the seller and I haven't heard back. It's only been a day, so we've got to give them a couple of days. Assuming they work, then a DCC system can be had for $16.68, so pretty cheap. What you do have to add to that, I already mentioned the jumper wires, not a big deal, is a power supply, and that's where the gigantic cost comes in. Amazon 14 volt 3 amp power supply cost $18.91 Canadian plus $9.95 shipping, so you got to pay for that shipping in there, and that gives you a total of $28.86. So this power supply costs more than the base controller itself. That means a DCC Plus system, so all these guys together, which is what you need, replaces a regular base system, is under $50 Canadian. It's $45.54. That's shipping included. The only issue is you got to wait a while for these things to show up. Now, you do need to run JMRI in order to access this thing. And you have a couple of options for that. If you have a laptop, you can use your laptop and hook it up to the USB. There's the USB connector right here. You can hook that up. If you have a desktop, you can dedicate an old one. You can run that. It doesn't take a lot. What I prefer to do is get a Raspberry Pi. Now, if you want to create this setup, the Raspberry Pi on Amazon
A Pi with a case and power costs $69.99 Canadian, and the 16 gig micro SD card you'll need costs $12.16 for a total of $83.25. So we've got $45.54 here with the power, and this guy, including its power supply, is $83.25, so we've got a total of $128.79. So you end up with a DCC system for $128.79. And what you will need in addition is a PC or Mac in order to download the software onto this guy, and you also need it for the micro SD card that goes in here. You need to go online to see how to do that. Search under DCC Plus and under Raspberry Pi and all that. There are videos out there that show how to do all of this. It's not difficult. It takes you a little bit to get your head around it. If you focus on just doing this instead of wandering all over the place like I did and saying, oh, but what if I want to install my big screen or my little screen, and what if I want sensors? How am I going to put them in? When I looked at all that stuff, then it detracted from me actually getting this going. The other thing I did add on this is a 3.5 inch screen, and that's under $30 Canadian. So that would bring the price up to right around the $150 mark to $160 Canadian. And what the screen does for me, oh, I forgot, if you're going to have the screen, you need input. So there's a, I think this is $15 keyboard. So maybe you're at $165 Canadian. I didn't price those two items out as of today, but prices keep dropping. But this whole system that I have here, power supply, the power supply for these guys, 4 amp, this is a 3 amp 14 volt, which delivers 13.1 volts to the rail. I measured that with this so that you can do some, you could actually program your locomotives through here if you wanted to, although it's a bit of a small screen. You can do all of that, as I say, for under 175 Canadian with the screen added onto it. And I've been doing testing here with my locomotive with this, and it works just fine. I'll continue to do more testing, and I'll find out whether the $9 Uno and $8 Motor Shield will work equally well as the quote real Arduino Uno and real Arduino Motor Shield. I found out that the real shield isn't available currently. There's supposed to be more coming into North America, so they'll hopefully be available relatively soon. But I wanted to update everybody, let you know that this is an inexpensive way of going if you want to get into full DCC. As I say, under $175 Canadian. I don't know what that translates into US. It's probably 110 to 120 bucks, somewhere in there. And if you like electronics and stuff, it's kind of a fun thing to do from my perspective. Now on to soldering.